So hi, good evening everyone. So welcome to the webinar, and as you all know that today in this webinar we are going to talk about the multicast communication, like basically how we talk about the communication which happens in the multicasting, like what exactly multicast communication is, and we are going to see. So my name is Jatin and I'm from PyNet Labs. So I'm going to take this session for today, and we are going to see like exactly which is written on the screen, that what exactly this multicast communication is, what is multicast architecture, and then we are going to see layer 2 multicast with IP MAC, as well as I'll show you like how these addresses are binded there. It's very like there are some versions. So without wasting any time, let's get started with our webinar. So whenever we are talking about the multicast communication, so it's something like, we can say it is a kind of technology which is used uh, from one to many communication, like we can say when it comes to multicast communication. So it is a technology for one to many communications. Like we all have heard about the communication terms, like when it comes to unicast, which means like one-to-one communication. When it comes to broadcast, it's one to all, and when it comes to one to a group, there we use this multicast. So a technology that optimize the network bandwidth and utilization and conserve the system resources accordingly. So this is what exactly this multicast communication is, that we can say. Or like we can say there are some things which we need to understand before starting the session. So we have some, like, we can say like that one source, because we do have one source, and that one source is going to send the packet to the multiple receivers. So one source, and we can say multiple receivers. So whenever we are talking about the like one source to multiple receivers, so which means like, it is a technique that transfers the packet from one source to many receivers simultaneously. Like for an example, let's say this is your device, and this device is, let's say, connected to some routers here. This is your R1, this is your R2, and this is some media server. Let's assume that this is a server, and this R2 is connected to, again, after, let's say, two routers again, router A and router B. And then these routers are like, connected to some devices here. Some end devices are there, we can say PCs or any end device. So whenever like you are talking about the unicast, so if this server wants to send some data to both of the devices, this is your device one and this is your device two. So in case of unicasting, let me write here unicasting. So in case of unicasting, the server is going to send three packets like that. One, two, and three packets will go, and from all these servers, three packets will go, and accordingly, like the packets will reach where they are destined for. But when it comes to the, we can say multicast communication, so it's not like that the media server is going to release three packets. Instead of that, what media server is actually going to do, it is going to send one single packet only. So this single packet, then when it is going to reach on the destination, then they will be like, divided according to. So that is why we say one to a group communication is known as your multicasting. So it is basically a technique which is used to transfer the packet from one source to many receivers simultaneously, and it is different from broadcast when we are talking about. So another way we do have, like whenever we are talking about multicasting, so we have providing, like, we whenever we talk about the multicasting, so it's like one to many packet delivery is also known as replicated unicast. What exactly separates the multicast from any replicated unicast in the behavior of source? So like, I'm writing here that a multicast source transmit from a single copy of any data, from a single copy of any packet, which I already shown you in the previous example, that when it comes to multicasting, only one single copy of the packet will be released. And like when it comes to replicated unicast, so replicated unicast is something like the source would have to send as many as copies of the known receivers. Like we can say here we have seen the diagram where three packets I just drawn like this. So if we are talking simultaneously about the multicasting, sorry, unicast, replicated unicast, so in that case the source is going to, would have to send as many as copies, which are like the number of receivers are there, and that too depends on the number of receivers. So when it comes to multicasting, guys, it relies on two protocols. So in multicasting, we have two protocols, like it relies on IGMP protocol, relies on IGMP protocol. So what exactly this IGMP protocol? So I'll let you know, but for as of now, we can simply understand that it is for the layer 2 operations. For layer 2 operations, like only we are this IGMP protocol relies for layer 2 only. Then we do have another protocol which is known as PIM, which means protocol independent multicast. So this basically, it is basically destined for layer 3 operations, we can say. So whenever we are talking about the layer 3 ops, so this is going to take place that PIM will be used. And when it comes to layer 2, so the IGMP protocol will be used. And there are different versions of IGMP, and there are dense modes in PIM. So we will discuss that part later on. So whenever we are talking about the multicast architecture, like just a quick scenario to make you understand what exactly multicast architecture is. So with a simple diagram, I'll be explaining you. So let's take a simple scenario that we do have some server here. Let's say I'm writing server, and this is a media server, we can assume. And this media server is somewhat connected to your R1 here. And this R1 is again connected to some R2 here. And now this R2 is connected to, let's say, 3, 4 routers here. R3 is there, R4 is there, and both of the routers are connected to R5 as well. So these are some routers which we have, and then this R4 is somewhat connected to a switch here. So this is your network switch. I'm writing switch, and this switch is connected to some receivers here at the end. Let's say we have one receiver, so we can say this is the multicast receiver 1, and we have another receiver which is 2, and we can say we have 3x as well. So basically now what I'm going to do is I'm going to divide this entire architecture into three options or three fields, we can say. So we can simply say this will be a different part. This will be a different part. So we have three, like I have divided the entire architecture into three sections, as you can see. So this server, like we can say this is the source. So this media server is sending some traffic. So multicast traffic will be sent here. So I'm writing MC traffic. So and represents as multicast. So you can see that whenever the multicast traffic will go from this link, which is connected via R1, so that it is going to use only two protocols, either UDP or RTP, reliable transport protocol. So like as this is a media server, so only UDP and RTP protocol will be used here. So let's say this is a video streaming server, and like this is our routing domain. So let's say here we have configured some OSPF in between all the routers. So when the data will go from this server to R1, so this R1 is considered as FHR, first hope router, because this is like we can say the nearest router to the source. So we call it as FHR, which is always near to the source. Then after, like when it comes in the layer 3 domain, like here we have done some routing here. So like I already told you, PIM is always going to used in layer 3 operations. So PIM will be there. So it is helping one router to forward the multicast traffic. So we can say like L3 PIM I can write. So all these routers are able to, get the information that multicast address is being used here. And like this router, this is the last router which is connected at the end, so we call it as LHR, last hope router. Then when the traffic is gonna be sent out on the switch, so on the switch too, like I already told you that IGMP domain would be there, because IGMP is the protocol which lies at layer 2. And we can say switches can be configured with IGMP snooping as well, and snooping and all these things comes in part of NRC. So yeah, you must be having a good idea about that as well. So if you don't have, you can go on the official website and check out. So all these receivers who will receive the multicast traffic here. So you can see why a simple architecture. This is the first hope router, which is like connected nearest to the source. Then the data was being forwarded to the this PIM domain where all the four routers are configured with some OSPF protocol. Or there might be other protocols as well, that depends upon the kind of routing which you have enabled. Then we have the switch, and that to the switch we have all the multicast receivers which are connected. So by just a quick example, I told you that these are some basic points, and this is how the architecture looks like about multicast communication whenever we are talking. So when it comes to like the advantages of multicast in comparison to the replicated unicast, so it's something like, we can say that we have better resource utilization. We have better resource utilization. So this is one of the best benefits about using the multicast communication instead of using replicated unicast, or we can say one copy versus a multiple copies, one copy of data versus multiple copies, or we can say that better bandwidth utilization we will be getting. So these are some benefits there whenever we are talking about the comparison of multicast with unicast. So no single link should be theoretically have, multiple copies of the same packet, which we already know, and bandwidth will be always utilized. So like there is one more thing, guys. Like we all know that there are network interface cards in the devices, which are known as NIC cards. So whenever we are talking about the NIC cards, so like NIC cards are like, they are uninterested kind of workstation. They always process the broadcast packets and then they send them on the workstations, like we can say. For example, you have some device here, and this device is connected to another device, like switch is there or router is there, like this kind of simple scenario you have. So whenever you are receiving any kind of broadcast traffic, the NIC cards are going to, process the entire packet, and then they are going to forward that particular packet to all the other destinations. So you will see, for good reasons, bandwidth traffic is generally not, like we can say, broadcast traffic is generally not recommended in the network, because with broadcast there comes many challenges, like loops will be there, broadcast storms will be there, multiple database instability will be there, frame copies would be there. So multicast traffic, provides one-to-many communication where only one data packet is sent on a link, and when it is needed only. So then it is replicated between the links that split on the network, or we can say device along with the multicast distribution tree. So there is a concept of multicast distribution tree as well. So yeah, these are some advanced things which we will discuss later on. So a server, like for example, whenever we are talking and comparing all these multicast things, so we have some terminologies in multicast which you need to keep in mind always. So I'm writing here multicast terminologies. So in multicast, we have three things. Like you all know about all these three things, but yeah, in multicast we call these things separately. Like whenever it come to the data packets, so we have data packets. Obviously, we do have data packets. So data packets are known as stream in multicast. So we call data packets as streams. Then we have multicast destination IP address, multicast destination IP. Multicast destination IP is known as a group address. So we call this multicast destination IP address as a group address, and we have recipient device of the multicast stream. So we can simply call them receivers, like the one who are going to receive. So receivers are always same. So we are not going to write this receiver. So these are some terminologies and some common multicast application if I'll be telling you, like where the multicast is widely used. Applications for multicasting. So we do have Cisco telepresence, like we can say IPTV is an example of multicast which uses multicast technology, and you can see gaming, we can say today, now these days we all play, we can say multiplayer games. So that multiplayer games which we are playing is something working at the back end, like the multicast communication is working at the back end, and like right now we are having some video conferencings, audio conferences. So here also the multicast traffic is somewhere used in between. So distance learning is a kind of example. So these are some basic things which I hope make sense to everyone, and this is what the basics of your multicast is. So moving ahead to the next part, like whenever we are talking about the layer 3 multicast IP addressing, how exactly the layer 3 multicast IP address is going to work and what is the scenario over there. So we'll see that when it comes to layer 3 multicast, so this layer 3 multicasting, and I'm talking about IP address here. There are two things which I mentioned in the starting, that we are going to see the layer 3 multicasting with IP address as well as with MAC addressing. So, guys, like we have to remember these things, and these are pretty much important. We can say these are the basics for layer 3 multicast IP address. That source IP in multicast packets always remains as unicast. Source IP in multicast packets remains in the form of unicast. Remains unicast. So we can say, like whenever we are talking, so just to make sure, like source IP plus source MAC, this will be the header information when any data will be traveling. So these information will always be unicasted. And we can say like the destination IPs are represented as multicast groups. Destination IPs is equal to multicast group, which I already told you previously. So this is known as your multicast group. And like, guys, let's say for example, the whole range of multicast starts from 224.0.0.0 to it ends up on 239.255.255.255. So this is what the range for multicasting. So this is what the range we reserve for multicasting. And the best thing about multicasting is that we don't have subnetting concepts here. So no subnetting is there. No subnetting concepts are there. And every single IP represents a multicast group here. Like every single IP. Like for example, we can say that 224.0.0/24, it controls the entire network control block, we can say. So like for example, if you are using use these IPs are used for the control traffic that is not forwarded out of a broadcast domain, like on the routers we are mostly going to use. So some examples we can write like this, that we do have some examples. We do have some IPs like 224.0.0.5. We have 224.0.0.6, and let's say 224.0.0.9, which is used for EIGRP, and like these are the IPs which are used for OSPF, right? So and this IP is used for EIGRP. So these are the basic things about the layer 3 multicast IP addressing. But we can say like whenever we come to multicast addressing, so we need to understand both of the things. So both of these things will be, you will be getting some things like you know all these things, but the reason behind telling all these things is because like when we are going to map the layer 3 multicast IP with the MAC address, so the mapping is pretty much different. So that is why we are discussing all these things. So when it comes to the layer 2 multicast MAC addressing, so now discuss the multicast MAC address as well. So when it comes to the multicast MAC address, so already I told you previously that source IP is equals to unicast, and destination IP is somewhat like which is already a multicast IP. Destination IP is equals to multicast. So this is what the basic difference we have seen as of now. So guys, like there is one-to-one correlation between IP and MAC whenever we are talking about the networking. So the goal is to have a sender and receiver agree on a single suitable we can say destination MAC address. So specifically like the interested receiver should accept the frame with the destination MAC at layer 2 only. So basically there was a like method which was required to send the multicast packet in the IP network, so that the replication of the we can say multicast traffic did not require the kind of packet manipulation, and there will be no burden on the routing protocols as well. So there was a method which uses a common destination MAC address. So a common MAC address was designed to support the concept of mapping of layer 3 to layer 2, because whenever we are see like in normal networking, whenever we are talking about the layers, so let's write here like whenever we are talking about the layer 2, so in layer 2 we have source MAC, source and destination MAC we can say. And whenever it comes to layer 3, so in layer 3 we have source and destination IP, as well as we have some ICMP message types and so many things. TTL values are there, but basic things like if we are talking about the headers of L1, L2 and L3, so source IP and destination IP plays a key role. So that is why it is said that like whenever we study the OSI, so we see packet and frames are the protocol data units for layer 2 and 3. But see, when it comes to the multicasting, there is a new kind of method we can say which is designed or which is created. So in layer 2 to layer 3 mapping of multicast addresses, there is a special MAC address reserved. So I'll let you know what exactly that special MAC address is. So that every multicast group IP address is mapped to that particular special address. With an example, I'll be showing you. Let's say you have some IP like 224.0.0.0.5. So in this IP, like it's consist of 32 bits in total, but yeah, we are going to see there are some conversion parts as well, that this IP will be specifically mapped with some reserve MAC address. So some reserve MAC will be there, and then we are going to add some bits here with the help of IP, and that will be considered as your multicast address. So how exactly we are going to do that? So for that you should understand all these things. So like a LAN segment can have multiple streams and receivers. So which traffic is to be sent out on the any of the device. So CPU, we can say CPU is going to process based on the MAC address which are assigned to the multicast traffic if we are using the multicast communication. So let's talk about how exactly we are going to map the layer 3 to layer 2. So there is a little calculation here. We need to understand that calculation. So we can say mapping layer 3 to layer 2. So we'll see this here. So before like discussing all these things, so the receiver only knows which layer 3 multicast address it will accept. So this is at the application layer first of all. So I can write here a receiver already knows which layer 3 multicast address it is going to accept. will accept. So, which means like this works at the application layer and it works in the down way of the stack and ultimately it results in the NIC card to that layer 3 multicast address which I was talking previously. But the same NIC card also needs to accept the layer 2 frame which is being carried by the multicast address before the layer 3. Like because in OSI model when we are talking, it's something like layer 3, layer 2, and then we have layer 1. So let's say we have packets on layer 3, we have frames on layer 2, and here we have signals, or we can take an example of NIC cards as well. So, but the thing is, the NIC card will also accept the frame of layer 2, like because if it is sending the data in the down stack like this. So the NIC card which is working here, it is also going to accept the frames here. So like whenever it is going to carry the layer 2 frames with that multicast before the L3 packet, which can be extracted for processing. So for unicast, the address will be like, it's something we can say burnt in address, which is provided by the sender using some ARP concept in the case of frames. But when it comes to the multicasting, the address must be dynamic as well, as we can say L3 multicast groups are highly arbitrary, we can say. So how exactly the MAC address is created here? Like I told you in the starting, like we do have a special MAC address which is reserved for multicasting. So let me write here to provide a simple mapping procedure. We are going to use a well-known multicast MAC address. So the first 24 bits of multicast address, the first 24 bits of multicast address multicast address are be like it's you we can say always starts with, so it will be like 010005E. So this is the multicast values, like these are the first 24 bits whenever we are mapping the layer 3 to layer 2. So there is a special MAC address which is reserved. So like for that special MAC address, these 24 bits are reserved. And we can say like these are the 24 bits. Let me write 24 bits like MAC address if you are talking. So 48 bits of MAC address is there. So 24 bits are reserved. And we have the 25th bit, like the 25th bit of the MAC address. It's not bits, it's bit only. The 25th bit is always 0. Now, see guys, let's take an example. Suppose that a multicast address which you are taking is, so let me write here. This is the multicast address we are going to take 224.0.0.5. So this is our multicast address. So as I told you, that first 24 bits are reserved. First 24 bits. So first 24 bits are 0100 and it's 5E. So these are the values which are reserved. So like if we are going to convert all these values, so for 0 we are going to get 0000, and for 1 we will be getting some 3 times 0 and 1. So this is the first value. Then we are going to write 00, so it will be technically 00 because 00 is of no sense to write, and 5 will be 0101. This will be the conversion for 5, and for E it will be, E is represented as, yeah, 10. So 111 and 0. So this will be the entire conversion of your this first 24 bits. So you can see like these 24 bits are reserved as this, and like I told you, 25th bit will be reserved as 0 only, right? As I have mentioned here in my slide, that the 25th bit will be reserved as always 0. Now the next 23 bits which you are going to be copied from the IP multicast group address. So like right now we do have the 24 bits here, but we have to write the entire 32 bits. So how exactly we are going to write? So what was the MAC address we have taken? Sorry, the multicast address, which was 224.0.0.5. Now we have 24 bits which are reserved here. So if we are going to convert this multicast IP address into binary form, so we are going to see that we will be getting somewhat like Hmm, okay, so for last 24 bits, I'm going to calculate only. Last 24 means this 005 I'm going to convert. So for the very first, like we will be getting 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. Then in the last we have 5. So it means like 1, 2, 3, 4, 5, and we are going to use 1, 0, 1. So this will be the conversion for 005. I'm not converting 224 because I do have the first 24 reserved bits here and 25th I know which is 0. So now the resulting destination MAC address will be, so resulting destination MAC address if we are talking about, so that MAC address will be like, see, we have converted all these values 0, 0, 0, 0, right? And then lastly we have 0, and for these 4 bits we have 5. So now the multicast MAC, like the destination MAC address will be like, we have 0, 0, 1 is reserved, 0, 1, 0, 0, 5e which is already reserved, and fifth bit we also know that that will be 0. So 0, 0, again 0, 0, then we will be having some 0, 5. So this will be the resulting destination MAC address, and this is how exactly we are going to map the multicast IP addresses with particular, whenever we are talking about these things, like how we are exactly going to map the addresses and how they are going to see that we will be using which MAC address and which according to the IP they are going to take the decision. Simply that means. So this is somewhat the basics of we can say the mapping part, like how this is how the mapping will be done. Now moving ahead to the next part, we have some multicast routes here, like some forwarding I'm talking about, like what exactly multicast forwarding is. So we have multicast forwarding. So in this multicast forwarding, like in unicast packet forwarding, the packets are always guided towards a destination. Like which means unicast packet forwarding if it is doing unicast packet forwarding. So whenever we are talking about unicast packet forwarding, guys, so the packets are always guided towards a destination. Packets towards the destinations. Then, like if we are talking about multicast packet forwarding, so when it comes to the multicast packet forwarding, the packet are always guided away from the source. Guided away from the source. Now, how exactly these sentences are signifiable? So see, like in there are two major type of interfaces as per multicast source. So we can say major interfaces types. Types per multicast source. So, like whenever we are talking about the major types as per interfaces per multicast source, so we can say we do have the first one, which is your upstream interface. So whenever we are talking about the upstream interface, so it's like we can say closest to the source, closest to the source. So that is known as the upstream interface. Then the second we have is the downstream interface. So in the downstream interface, it is something like, interfaces with some receivers, we can say. Interfaces with receivers, or we can say the end devices. So, like, the entire concept is termed as reverse path forwarding. So, this is a like, method which is used for multicast loop preventions. Like, there are loop preventions technologies as well in multicast routes. So, we have some routes here in multicast. So, these terms, like, you must be having a good idea if you know. So, multicast routes, we can say. So in multicast, we have some roots like we have S, we have G, or we have some star, and we can say we have some G as well again. So like multicast routing table also stores and organize the information by the multicast group, which is known as the forwarding state. So we can say like that each multicast group has a source. Each multicast group has a source. And what exactly that source here is, like when we are talking about this S, this means specific source. And we have like whenever we see this star sign, so the star sign represents that any or unknown source, we can say. And like the table after, like whenever we are doing some multicast routing, so that I already told you, the table stores the information by multicast groups. So the table is further organized into by a combination of sources for the groups. Let's say the tables, the multicast tables, multicast routing tables we are talking here. So the table is further organized by a combination of sources by the group of sources for the groups, we can say. Now, in these sources, we do have this SG, which means like we can say forwarding state with this SG if you are getting. So you can see forwarding state with specifications. This means it's in forwarding state with some specification. And if you will see some star and G like this, so in that case, you means forwarding state with any source or any destination. Forwarding source, sorry, forwarding state, not source. Forwarding state by any unknown source. So to verify all these things, in the multicast routing, there is a command which we use, show IP M route. M means multicast route. So this is the command through which you can verify the multicast routing. So exactly this is what are these the basics of some multicast forwarding, which as discussed we will be letting you know. Then like after this, moving to the most important part of the webinar, which is like, whenever we are talking about the memberships here, like, we can say there are versions of multicast. So like I told you, IGMP is going to use some versions, oh sorry, multicast is going to use some versions like for layer 2 IGMP and for layer 3 PIM will be used. So when it comes to like IGMP versions, so like we can say there are three versions in IGMP. IGMP versions. So we can say we do have three versions. The first we have is IGMP version 1. The second we have is IGMP version 2. And the third one we have is IGMP version 3. Now there are some differences between all these versions. Like whenever we are talking about the version 1, so it is very like old kind of version and it's rarely used. So in today's network we don't use this IGMP version 1. Then we have some version 2 which is commonly used in multicast networks. Commonly used in multicast networks. Then we have IGMP version 3 which is used by SSM. So this SSM means source specific multicast. Source specific multicast. So these are some common things which you have some idea about what exactly and how these are going to work. Then we do have some like in every version, if we are separately talking about the version 1, 2, 3. So it was like the first IGMP version that allowed to announce its that multicast traffic. So it has two types of messages, like when it comes to the type of messages in IGMP. So in IGMP version 1, two types of messages are there. The first type of message was the membership query. The the membership query, and the second we have is the membership reply. So whenever we are talking about the query and a message reply, so the query was always sent via 224.0.0.1. This was the multicast address which was used by the routers to report that they are always gonna be sent on the stations that whichever the routes they want to join. So if there was no message announced to the station, like where the route, like where the message is to be delivered, so in that case, the multicast will stream the feed to the segments according to the sessions which are left, and it is gonna wait for that reply. So the reply was like from the receiver side. Then we have some IGMP version 2. So there are again like in IGMP we have some membership query same. So I'm writing membership query like this to understand. In the membership, which is always sent via the same 224.0.0.1. So it's generally sent to the group, and group we can say to multicast groups whenever we are using. So the group specifies the membership query, which is used to find out. And then there is a leave message, like after second, we have membership reply. So after the reply, we do have one more type of message here that was like, a leave message. So in that leave a new message advertised to the routers that they are belonging from that particular multicast group if they are using. So this is how like these versions are different from each other. When it comes to IGMP version 3, it was like introduced to support the need of source specific multicast addresses that does not have much capability to particularly send the extensions of IGMP protocols over IGVMP. So like whenever we are talking about all these IGMP versions. So this is how they are gonna be different as per like the normal scenario which we have taken here. So as such like no labs are included. So these are some theoretical concepts which you need to understand. And like if IGMP is clear to you, then when it comes to the PIM, so which is protocol we can say independent multicast. So we have some, operating modes here when it comes to the PIM. So let me write operating mode. So in this operating modes, if we are separately talking, so we have some modes here which we need to understand. That we have some PIM dense mode, which is gonna basically be used on right layer 3 operations only, PIM dense mode, which is known as PIM-DM. Then we do have PIM space mode, which is considered as your PIM SM. Then we do have sparse dense mode, which is known as like we can't say it's specifically known as in short form, but then we have PIM source specific. So it's PIM source specific, PIM source specific multicast. So we can write it as like PIM SSM, which is separately being used. So these are some, modes, and we do have some bidirectional mode as well. So see this PIM DM, like this PIM DM and this PIM SM are commonly referred to any source multicast address. So we refer these as any source multicast, which is known as ASM. Any source multicast that is considered as ASM. So whenever like we are going to talk about these dense modes, so dense mode is something which is configured over the routers, and it is safe to assume that the receiver of the multicast groups are always located in the same network. So these are going to use some algorithms, like there is some multicast tree which is created whenever we are going to use these kind of scenarios. And when it comes to the space mode, it's something like designed for the network with some multicast application receivers and scattered throughout the network. So however, like we do have a lot of things to discuss about the multicast, and as such, like related to the webinar content, we have discussed most of the things. So any queries you people have, so you could let me know your queries as well, because this is something as per the content which we have discussed. And some extra things like about messages type we have also discussed, like what are the messages types. And for like more in detail, we are going to definitely upload a blog over this, and you can have more detailed description of multicast in that blog and video. So that's all from my side. Any queries if you have related to the versions, related to the topic which we have discussed, so please let me know.